Newton's third law is completely different than Newton's first and second law. Newton's first and second law explains if the net force acting on the object is zero. First law explains that one. Second one talks about if net force acting on the object is not equal to zero, how object behaves, what single object behaves. It's talking about that. But Newton's third law is about the interaction of two objects. Consider a moving car colliding with the concrete barrier, as you see in this picture. So if you look at the picture, you are going to say that some deformation on the wall. This deformation is because of the force exerted by the car on the wall. So there is a force, there is a push by the car on the wall. So first push is this. And because after the interaction, you are going to also observe that there's a change in the shape of the car. Of course, remember, a force also can cause a change if it acts on it. So then, which means there must be some force acting on the car by default. So this is the second push. Second push. So the wall pushes the car in opposite direction. Then Newton's third law is talking about that when two objects interact, a pair of forces is created between these two objects, and not only one force. I mean, car is moving, car is hitting the wall, so only car applies a force on the wall. No, wall is also applying a force on the car. So that's why in nature, an isolated single force cannot exist. That's all the forces in nature has a pair. We have pairs of forces, not single force in the nature. Newton's third law states that if two objects interact, so by the time this interaction can be between two objects which are not in contact as well, two objects which are not in contact can also interact, just like the sun and earth. So sun and earth also in interaction, they can also apply force on one another. Newton's third law is talking about this interaction. It states that the magnitude of the force exerted on the object 1 by object 2, which is F2 in here, will be equal to magnitude of the force exerted on object 2 by object 1, so F1. So the force F1. These two forces are equal in magnitude and opposite in direction. And if one of them is called action force, I mean the force acting on the first object by the second, if you say action, so you can also name that the force exerted on the second object by the first one is the reaction forces. So if there's action force, so absolutely, indefinitely, there must be a reaction force. That's why this Newton's third law of motion also explained in an alternative way. For every action, there is an equal but opposite reaction. Then if we give a summary about Newton's third law, first, Newton's third law is about interaction between the two objects. Objects can interact with contact or non-contact. Both cases are possible, and field force also can produce action-reaction. Because force created in pairs, a single isolated force is not possible. So we are going to say that these forces as action-reaction pair forces. These action-reaction pair forces first equal in magnitude. Their magnitudes are equal. So sometimes students think that, oh, teacher, sun is greater in mass, but earth is smaller in mass. So sun must attract earth with a greater force, but earth attracts something that's smaller force. No, both forces acting on each object, the force acting on each object must be equal in magnitude first. Second, opposite in directions. As you see, their directions will be opposite. And third, and maybe most important part, these two forces will be acting on different objects. If you say the force acting on earth is action, it is on the earth, so reaction will be on the sun. So it is impossible for action-reaction pairs to be acting on the same object. They will absolutely be acting on different objects. Two examples in here, I put the pictures. One of them is a man is pushing a fridge in positive x reaction. In this case, if you say that action is on the fridge, reaction will be on man. So they are on different objects. Or when you use a hammer for a nail, if the action is on nail, if this is action you say, so reaction will be on hammer. This is going to be reaction. So don't forget, action reaction forces can never be on the same object. And now we are going to solve some section questions, and we are going to finish this section. Identify the action reaction pairs in the following situations. The first one, a person takes a step. We will learn in the next section, while we are talking about the frictions. This walking is available only if you are if there is a friction force, static friction force between your shoes and the ground. So by using this friction, so you are pushing the ground backward direction. So if this is action on the ground by your foot, so ground is given reaction to your foot, so reaction is going to be in opposite direction of the action, but it will be on the shoes. And action is on the ground, and reaction will be on the foot, on your shoe. And this reaction force by the ground on your shoe led you to walk on this road or on this floor. Second one is a snowball hits someone in the back. So in this case, snowball will apply a force on your back. So this is if this is going to be action on your body, so reaction must be on the snowball. Reaction force must be in the snowball. They must be equal in magnitude, opposite in direction, and acting on different objects. And C, a baseball player catches a ball. So let's change their places. So the one force must be acting on your gloves while you are holding, second on your hand. Say the reaction force must be on the ball. So this is what action reaction is. So the baseball ball exerts a force on your gloves, on your hand. If you say this is action is on your hand, but reaction must be on the ball. And a gust of wind strikes the window. So this is the gust of wind. So in this case, if gust of wind strikes the window, so action must be on the window, so but reaction must be on air molecules. Reaction must be on air molecules or particles of air carried by the wind. And last question is a critical thinking. If a small sports car collides head-on with a massive truck, which vehicle experiences the greater impact force? Which vehicle experiences the greater acceleration? Explain your answer. First, we should know that if two objects are in contact, we don't care their masses, which one is smaller, which one is greater. So there is an interaction between them. Because of this interaction, there will be acting two forces. One force, it will be on the car, so on the track. So if you say this force on the track as action force, so reaction will be on the automobile or sport car. So this is going to be reaction. And we know that these forces are equal in magnitudes. So there is no greater impact force, equal impact forces, equal in magnitude, opposite in direction, and acting on different objects. So which vehicle experiences the greater acceleration? Of course, the one which has smaller mass will experience a smaller acceleration, because we know that acceleration is equal to F over m. So because both forces are equal in magnitude, F's are equal, this is A for car, this is A for track. Again, the force is F, but mass of the track is big. If mass is big, so acceleration is small. If mass is small, acceleration is big. That's why acceleration of the car is greater than acceleration of the truck. Okay, this is all about the section 3, which is about Newton's second and third laws. Next section, we are going to talk about everyday forces. See you next lesson.